Imagine looking up at the night sky. So many stars, so many possibilities. For millennia, humanity has gazed upwards, wondering, are we alone? Is there anyone else out there? Then, in 2016, a faint whisper reached us, not from a distant galaxy, but from our very next-door stellar neighbor. This was the year astronomers, peering through powerful telescopes at the La Silla Observatory in Chile, announced something truly extraordinary. They had found a planet orbiting Proxima Centauri, the closest star to our own sun. This wasn't just any planet, it was a new character in our cosmic story, waiting just 4.2 light-years away. The discovery of this planet, named Proxima b, was a triumph of human ingenuity and persistence. Scientists used a clever technique called the radial velocity method. They watched Proxima Centauri with an instrument called the HARPS spectrograph. They weren't looking for the planet directly, but for the tiny wobble the planet's gravity caused in its star. It's like watching a dancer twirl. A smaller partner will make the lead dancer sway ever so slightly. This tiny, telltale dance of Proxima Centauri revealed the presence of its unseen companion. It was a monumental achievement, confirming that planets could indeed exist even around the smallest, faintest stars. The news sent ripples of excitement throughout the scientific community and beyond. Why? Because proximity matters. While we have found thousands of exoplanets, planets outside our solar system, most are hundreds or thousands of light-years away. Proxima b, however, is practically in our cosmic backyard. It's so close that future generations might even dream of sending probes to visit. This nearness makes it a prime candidate for intense study, a celestial laboratory where we can test our theories about planet formation, habitability, and perhaps even life itself. The universe had just handed us a tantalizing clue. Think about it. For centuries, we only knew of the planets in our own solar system. Now, we had concrete evidence of a world orbiting the very next star over. This wasn't science fiction anymore. This was real. The discovery of Proxima b opened a new chapter in our exploration of the cosmos. It fueled our imaginations and intensified our search for answers to those age-old questions. The universe is vast, but suddenly, it felt a little less empty, a little more full of potential neighbors. The adventure was just beginning, a journey to understand this new nearby world. So, what do we know about this intriguing neighbor, Proxima b? Scientists have been working diligently to sketch its portrait. It's often called a super-Earth. This doesn't mean it has superheroes, but that its mass is likely greater than Earth's. Current estimates suggest it's about 1.17 times the mass of our home planet, possibly a bit more. This makes it a rocky world, like Earth, Mars, or Venus, rather than a gas giant like Jupiter. Imagine a world just a little heftier than our own, spinning through the cosmos so close by. This rocky nature is crucial. It means there could be a solid surface. Proxima b dances to a much faster rhythm than Earth. Its year, the time it takes to orbit Proxima Centauri, is a mere 11.2 Earth days. Compare that to our 365-day journey around the Sun. This swift orbit means it's incredibly close to its star, about 20 times closer than Earth is to our Sun. You might think this proximity would make it a scorching inferno. But remember, Proxima Centauri is a red dwarf star, much smaller, cooler, and fainter than our Sun. So despite being so close, Proxima b finds itself in a very special place. This special place is called the habitable zone, or sometimes the Goldilocks zone. It's the region around a star where temperatures are just right, not too hot, not too cold, for liquid water to potentially exist on a planet's surface. And liquid water, as far as we know, is a key ingredient for life. So Proxima b, a rocky world in the habitable zone of its star, immediately became a focal point for astrobiologists. The possibility, however slim, that water might flow there, that conditions might be suitable for life, was incredibly exciting. Further observations, particularly with the powerful espresso instrument on the Very Large Telescope in Chile, helped refine our understanding. These measurements in 2020 and 2022 confirmed Proxima b's mass and its orbital characteristics with remarkable precision. They strongly supported the idea that it is indeed a terrestrial or rocky planet. This doesn't guarantee an ocean or an atmosphere, but it keeps the door open. It tells us that the fundamental building blocks for an Earth-like world are present, so tantalizingly close to home, inviting us to look deeper and learn more. While the idea of an Earth-like neighbor is thrilling, Proxima b faces some serious challenges. Its host star, Proxima Centauri, is not as benign as our Sun. It's a red dwarf, and these types of stars are known for their tempestuous nature. Proxima Centauri is highly active. It frequently unleashes powerful stellar flares. These are sudden, intense bursts of radiation, much more violent than the solar flares our Sun produces. Imagine solar storms up to 100 times stronger than anything we experience, regularly blasting the planetary system. This is the environment Proxima b calls home. This intense radiation, particularly X-rays and extreme ultraviolet light, bathes Proxima b. Observations from NASA's Chandra X-ray Observatory and ESA's XMM Newton, along with earlier data from the Hubble Space Telescope, have confirmed this harsh reality. Such a constant bombardment could have dire consequences for any potential atmosphere the planet might possess. Many scientists initially worried that these flares would have stripped away Proxima b's atmosphere billions of years ago. Without an atmospheric shield, the surface would be exposed to lethal radiation, likely rendering it sterile. It's a tough neighborhood for a budding Earth. Another significant challenge for Proxima b is something called tidal locking. Because it orbits so close to its star, the gravitational pull is immense. Over eons, this has likely caused Proxima b to become tidally locked. This means one side of the planet constantly faces Proxima Centauri, experiencing perpetual daylight. The other side is forever turned away, shrouded in eternal night. Think of our moon. It's tidally locked to Earth, always showing us the same face. For a planet, this creates extreme temperature differences between the day side and the night side. These conditions, the ferocious flares and the stark division of eternal day and night, paint a picture of a world very different from Earth. The day side might be baked, while the night side could be frozen solid. This led to considerable skepticism about Proxima b's true habitability. Could life possibly arise or even survive under such extreme pressures? Or is Proxima b a barren rock, a testament to the violent nature of red dwarf systems? These are the questions that drive scientists to look even closer, to seek more data, because the universe often holds surprises. Just when the picture of Proxima b seemed to be settling into one of a harsh, likely lifeless world, something new emerged. Recent reports, emerging in the 2024 to 2025 timeframe, have injected a fresh dose of mystery and excitement into the story. Astronomers, scrutinizing data from this nearby exoplanet, have detected something unexpected, a faint yet measurable glow emanating from Proxima b's permanent night side. This isn't the kind of light you'd expect from simple reflection of starlight from its sun. This is something originating from the dark hemisphere itself, a place that should be plunged in perpetual blackness. This newly observed luminescence is not easily explained. If one side of the planet never sees its star, where could this light be coming from? It's a puzzle. The light isn't just a steady, faint sheen either. Some reports suggest it might even be pulsating or varying in intensity. This characteristic makes it even more intriguing and harder to dismiss as a simple observational artifact or a known natural process. The dark side of Proxima b, once imagined as a frozen wasteland, might be hiding an unexpected secret, a faint beacon in the cosmic night. The scientific community is buzzing with this new information. Whenever an observation defies easy explanation, it opens the door to new possibilities, some more mundane, others potentially revolutionary. This faint glimmer from Proxima b's night side has certainly done that. It challenges our existing models of tidally locked planets and forces us to consider phenomena we might not have anticipated. Is it a known atmospheric effect behaving in an unexpected way? Or is it something entirely novel, something that could reshape our understanding of planetary dynamics or even astrobiology? This discovery, if confirmed and thoroughly characterized, could be a game changer. It has reinvigorated the study of Proxima b, transforming it from an interesting but perhaps inhospitable neighbor into a prime target for cutting-edge astronomical investigation. The faint light beckons, a whisper from the darkness, daring us to uncover its source. The quest to understand this enigmatic glow is now at the forefront of exoplanet research, pushing our instruments and our theories to their limits as we try to comprehend what's happening on this world just a stone's throw away, cosmically speaking. With this mysterious night-side glow detected, scientists are now racing to figure out its origin. Currently, there are three main hypotheses being explored: ranging from the relatively conventional to the truly extraordinary. The first, and perhaps most straightforward explanation, involves atmospheric dynamics. Even on a tidally locked planet, if it has a substantial atmosphere, winds could transport heat from the perpetually sunlit day side to the frigid night side. This heat could manifest as infrared radiation, a form of light, or potentially drive chemical reactions in the upper atmosphere that produce a visible glow, like an aurora. A second possibility points to geological activity. Proxima b is a rocky planet, and like Earth, it could have a hot interior. This internal heat could power volcanoes, spewing molten rock and superheated gases onto the surface. Extensive volcanic eruptions on the night side could certainly create localized or even widespread areas of light and heat. Imagine vast lava fields glowing faintly in the eternal darkness, or plumes of incandescent gas rising into the thin air. Such geological processes are known to occur on Earth and other rocky bodies in our solar system, so it's a plausible natural explanation for the observed phenomenon. Then there's the third hypothesis, the one that quickens the pulse and fires the imagination: artificial light. Could this glow be a sign of technology? Could it be the lights of alien cities, or some other large-scale energetic activity generated by an intelligent civilization? Some have speculated that if life exists on Proxima b, it might thrive on the night side or in the twilight terminator zone, sheltered from the star's harsh radiation. Perhaps such a civilization would use technology, like vast photovoltaic arrays on the day side, to power illumination and sustain their habitat on the dark side. It's a breathtaking thought. Of course, scientists are, by nature, cautious. Prominent researchers like Avi Loeb have urged careful consideration of all natural possibilities before jumping to extraordinary conclusions. For instance, Proxima Centauri's own powerful flares could cause temporary brightening effects on the planet, or the specific geological makeup and topography of Proxima b's surface might reflect or re-radiate energy in unexpected ways. All these natural explanations must be thoroughly investigated and ruled out. But the mere possibility that this light could be artificial hangs in the air, a tantalizing prospect driving further observation. To unravel the mystery of Proxima b and its puzzling night-side glow, humanity is deploying its most powerful astronomical tools. Chief among these, currently, is the James Webb Space Telescope, or JWST. This magnificent observatory, orbiting far beyond Earth, is honestly a marvel of engineering. Its giant mirror and sophisticated instruments are designed to peer into the universe with unprecedented clarity, especially in infrared light. Infrared is key here because it can pierce through cosmic dust and reveal the heat signatures of distant objects, including the atmospheres of exoplanets. JWST is focusing its keen senses on Proxima b, employing a technique called infrared spectroscopy. As starlight from Proxima Centauri passes through Proxima b's atmosphere, if one exists, different molecules in that atmosphere will absorb specific wavelengths of light. And when the planet itself emits light, its chemical makeup will also leave a fingerprint. By analyzing these patterns of absorbed and re-emitted light, JWST can search for the chemical signatures of an atmosphere, things like water vapor, carbon dioxide, methane, or oxygen. These are potential biosignatures, hints of life, or even technosignatures, such as industrial pollutants. Before JWST, other powerful instruments laid crucial groundwork. For example, the espresso spectrograph on the European Southern Observatory's Very Large Telescope in Chile provided the high-precision measurements that confirmed Proxima b's mass and orbit, really solidifying its status as a rocky planet. Ground-based telescopes continue to monitor Proxima Centauri for its flare activity, which helps scientists understand the radiation environment that Proxima b endures. This ongoing data collection is vital, building a comprehensive picture of the system and providing context for new discoveries like the night-side light. The quest to understand Proxima b is a continuous process of observation, analysis, and refinement. Each new piece of data, whether from JWST or ground-based observatories, helps us to build a more complete model of this nearby world. Scientists are meticulously sifting through the signals, looking for clues, testing hypotheses. The faint light from the night side has added a new urgency to this work. The tools we have now are powerful, but the universe is full of subtleties. The challenge is immense, but so is the potential reward, a deeper understanding of our place in the cosmos. While current telescopes like JWST are making incredible contributions, An even more powerful generation of observatories is on the horizon, promising to revolutionize our view of Proxima b and other exoplanets. Under construction in Chile's Atacama Desert is the Extremely Large Telescope, or ELT. As its name suggests, it will be colossal, boasting a primary mirror nearly 40 meters across. This will make it the largest optical and infrared telescope on Earth. The ELT will be equipped with advanced adaptive optics to correct for atmospheric distortion, and instruments designed for directly imaging Earth-like exoplanets. With instruments like METIS for infrared imaging and Harmony for spectroscopy, the ELT aims to directly see planets like Proxima b. This is incredibly difficult, like spotting a firefly next to a searchlight, but the ELT's sheer size and advanced technology will allow it to analyze Proxima b's surface features, measure its temperature with greater precision, and probe its atmosphere in unprecedented detail. It could search for biosignatures indicating life, or even signs of volcanic or industrial activity that might explain the mysterious night-side glow. The ELT promises a much sharper view of our neighbor. NASA is also planning ambitious future missions. The Nancy Grace Roman Space Telescope, set to launch around 2027, will have a wide field of view, enabling it to discover thousands of new exoplanets using a technique called microlensing. While not primarily focused on Proxima b, its technological developments, especially its coronagraph demonstrator for blocking starlight to see faint planets, will pave the way for even more capable future missions. Concepts like LUVOIR, the Large Ultraviolet Optical Infrared Surveyor, and HABEX, the Habitable Exoplanet Observatory, are being designed for the 2030s and beyond. These future space telescopes like LUVOIR with a potential mirror up to 15 meters, or HABEX with its innovative starshade technology, are specifically designed to find and characterize Earth-like planets. They will be able to directly image planets like Proxima b and analyze their atmospheres for signs of life, including oxygen, water, and even artificial pollutants. Furthermore, NASA's Habitable Worlds Observatory concept, recommended for funding, will be the first telescope purpose-built to search for life on exoplanets, including looking for artificial night-side illumination. The coming decades promise a flood of new data, bringing Proxima b into sharper focus than ever before. The intense focus on Proxima b isn't just about one planet, it's about understanding our place in the vast cosmic ocean. Discovering any form of life on Proxima b, even simple microbes, would be one of the most profound discoveries in human history. It would tell us that life is not unique to Earth, that the spark of biology can ignite on other worlds. This would fundamentally change our perspective on ourselves and our universe. It would mean that the conditions for life might be common throughout the galaxy, and that we are part of a much larger biological story. Studying Proxima b also helps us understand a crucial aspect of planet formation and habitability: worlds around red dwarf stars. Red dwarfs, like Proxima Centauri, are the most common type of star in our Milky Way galaxy. They are incredibly long-lived, far outlasting stars like our Sun. If planets orbiting these numerous durable stars can indeed support life, despite challenges like flares and tidal locking, then the number of potentially habitable worlds in the galaxy skyrockets. Proxima b is our closest laboratory for testing this very idea. What we learn there will inform our search for life everywhere. The quest to understand Proxima b is also a reflection of a deep human drive, the desire to explore, to know, to push the boundaries of our understanding. It connects us to generations of thinkers and explorers who looked to the skies and wondered. This search employs our most advanced science and technology, pushing innovation and inspiring new generations to pursue careers in STEM fields. The challenges are immense, requiring international collaboration and decades of dedication. But the pursuit itself enriches us, expanding our intellectual horizons and reminding us of the power of human curiosity. Moreover, if life has found a way to thrive on Proxima b, especially on its potentially sheltered night side or in a twilight zone, it would offer incredible lessons in adaptation. Life on Earth has conquered extreme environments, from the crushing pressures of the deep sea to the acidic volcanic vents. Life on a tidally locked planet, constantly bombarded by radiation on one side, might have evolved unique strategies for survival. Understanding these strategies could broaden our very definition of what life is and where it can exist, opening our minds to possibilities we haven't even conceived of yet. So we stand at a fascinating crossroads in our cosmic journey. The faint, enigmatic light detected on the night side of Proxima b presents us with a compelling mystery. Is it merely the result of natural atmospheric phenomena, a subtle dance of heat and chemistry in an alien sky? Or perhaps it's the fiery breath of volcanoes, a geological process shaping a young or active world. These are plausible explanations, and science diligently works to explore them. But there's that other, more electrifying possibility that whispers in the background of every observation and calculation. What if that light is not natural? What if it is indeed artificial? The implications of such a discovery would be nothing short of world-altering. It would mean that intelligent life, capable of large-scale technology, exists beyond Earth, and it's right next door, cosmically speaking. It would answer, with a resounding no, the age-old question of whether we are alone in the universe. It would signify that another technological civilization shares our small corner of the galaxy. The philosophical, societal, and scientific reverberations would be immense, reshaping humanity's understanding of its own significance. The search for answers continues, fueled by this tantalizing glimmer. Our telescopes, both on the ground and in space, are our extended senses, reaching out across the light years to probe the secrets of Proxima b. Each new piece of data is scrutinized, each hypothesis tested. The scientific process is patient, methodical, and rigorous. It demands evidence, and extraordinary claims require extraordinary evidence. But the very possibility, however remote, that we might be on the verge of detecting another civilization keeps us looking, keeps us searching, keeps us dreaming. Ultimately, Proxima b reminds us that the universe is full of wonders, still largely unknown. Whether its night-side light turns out to be a natural spectacle or a beacon from others, the journey of discovery itself is invaluable. It pushes us to be better, to learn more, to look further. The cosmos has presented us with a profound question, written in faint light on a nearby world. Are we observing a silent natural process, or is someone or something out there perhaps shining a light for us to find, waiting for a cosmic hello? The universe waits for our answer.